So the topic that we will cover now is the principles of fire and explosion protection, because we have covered all of the principles of the fires and explosion, how they work, how they behave. So now that we know how fires start, how they behave, it's now time to know how do we handle the fire, how do we protect ourselves, how do we protect our assets from fire, and how to control them. Okay, so we'll be covering topics such as layers of protection, ignition source control, emergency shutdown system, and fire suppression methods. Now, the protection of petroleum facilities follows the same overall philosophy that will be applied to any building or installation. So the basic requirements would be, first of all, personnel evacuation. You need to know how to evacuate your staffs. And second is containment. How do you contain a fire? Or how do you isolate that fire? And finally, if you have a fire, how do you suppress that fire? And now, fire and explosion protection engineering, basically, the philosophy is defined by 6 objectives. So the first objective is to prevent the immediate exposure of individuals to fire and explosion hazards. So it's basically you're saying that no facility should be designed such that an employee or the public nearby that facility could be immediately harmed if they were to be exposed to that operation. So that's the first objective. We want to prevent any immediate exposure of anyone to that fire or the explosion hazards. Now, the second objective is to provide inherently safe facilities. So employers have to make sure that the design safety features at the facilities would provide adequate spacing. So you have enough spacing between structures or between buildings in a plot of land, for example. And the arrangement as well as segregation of equipment from high hazard to low hazard has to be done. So this is also one topic that we will be discussing later on, how arrangement and segregation is vital in the oil and gas industry. And then the least hazardous process system should always be used to obtain the desired product or production objectives. Always choose the least hazardous process system. And then protective systems must be provided to minimize the effects that may occur from any catastrophic incident. Now, the third objective is to meet the prescriptive and objective requirements of the governmental laws and regulations. So there's always laws and regulations that you have to obey and follow in operating in industries. Now, the fourth objective is to achieve a level of fire and explosion risk that is acceptable to the employees, to the general public, to the petroleum and related industries, as well as to the local and national government and that company itself. The fifth objective is to protect the economic interest of that company for both short and long range impact. So that's why you have to look at the economic factor, making sure that the company will not get any losses from any kinds of accidents. And number 6 is to comply with the corporation's policy standards and guidelines. So not just you have to follow the rules and regulations by the government, but you also have to comply with the company's own policies, the company standards and guidelines. Now, let's first look at layers of protection that we can have. So most facilities are designed around layers of protection, commonly referred to as the independent layers of protection. If you remember your Swiss cheese, your Swiss cheese is basically like independent layers of protection. You have many different layers of cheese which acts as a barriers of protection from an accident or an injury. So a protection layer qualifies as an ILP only when the following conditions are met. Okay, Firstly, that protection must reduce the risk of a serious event by 100 times. So it's very efficient, and that protective function is provided with a high degree of availability. It must be always available, and it has the following characteristics, which is specificity. It has to be very specific. It has to be independent. It is dependable, and it is also auditable. Now, example layers of protection is like, well, this basically looks like an onion if you kind of have. So the core layer of a protection is the basic process control. Let's say in a reactor, for example, or in a distillation column, you need to have the basic process control, such as the sensors, the heat sensor, temperature sensors, for example, and pressure sensors or composition sensors. All those different types of sensors must be in place. So that is the basic process control. And also to have all the valves equipped. And then the second layer will be alarm. Yes, you have your sensors already, but if the limit is exceeded on the set value of that sensor, then it should trigger an alarm to draw attention of the nearby people to act to stop the risk. So the alarm system should be connected to the basic process control system. And once the alarm is being triggered or is set off, it should also be connected to a safety interlock system, SIS, to stop. It is either to stop or to start anything, an equipment. Let's say it should automatically shut down a valve, for example, or it should immediately shut down a heater system. Okay, for example, or if something is too hot, maybe you can start a cooling system. Okay, so those are example of safety interlock system. And the fourth layer will be the relief, just like the relief valve on a tank, where you have an automatic relief valve to prevent excessive pressure, like we've seen in the previous Blevy example. If there's an overpressure happening inside a tank, it will automatically turn on the relief system to relieve or to evacuate some amount of pressure or gas from that tank in order to prevent it from having excessive pressure inside the tank. So these should be automated. It should not be manually operated, because then it just this is the purpose. So these should be automated. So once the alarm system is on, you draw the attention of people, and then the relief system is also on. Then it is time for human intervention to do containment, where you reach out workers, community or environment, whether you evacuate them, whether you start to suppress the fire using a fire extinguisher and so on. And then finally, you should have this emergency response to evacuate or to contact a fire department and start firefighting, and healthcare, ambulance, police, and so on. So those are emergency response. So if you look at layers of protection in this form, you have at the very bottom of the layer, or the core, would be the basic process control system, and you have a set value, a set process value, for example, set value for temperature, or set value for level, for example, level layer, or pressure. So there can be many different of process values, and if the value exceeds what is being set, then it will immediately triggers the process control layer like an alarm system. So it will cause the alarm to sound. It will sound the alarm, and then also if the value keeps on moving up, and then there should be an emergency shutdown, for examples. So this is safety instrumented system, which is one layer of safety layer. And then once after the emergency shutdown, and you start to have a fire, for example, so you will have to have an active protection layer. This is where you have that relief valve, the rupture disc. It should automatically work at this point, and so that is considered as an active protection layer. And at the same time, you can also have a passive protection layer, for example, having a dike. So dike is like a wall that contains the fire, so you can have a dike as a passive protection layer. And finally, you need to have human intervention. You have planned and emergency response system where you would evacuate and have firefighters coming in, or first responders coming in, ambulance, police, and so on. Okay. So basically, at first you have the basic process control system, and then there's a prevention system, and finally a mitigation system in protecting fire accidents or fire hazards. Okay, now let's talk about segregation, separation, and arrangements. Now this is about the facilities and the process plan. Okay. So segregation is grouping of similar hydrocarbon processes into same major area. You put them together, so you don't mix them. You segregate hazard areas and separate them as far as necessary from other areas of the facility and public. So major facility segregation categories are process. You can segregate a process equipment in one place. You can put storage facilities in one area, so that's why you normally have a tank farms where they're all storage tanks. And then you can have a separate loading area, a separate flaring system, separate area for utilities, and a separate building for administrative. So the primary design considerations should be to protect the employees as well as the general public from the effects of any explosion or fire that should occur. So the ideal situation for an offshore facility is to locate the accommodation on a separate installation jacket, and that is also spaced as far as possible, or not really as far as possible, but as far as practical from the production process, and as well as the process platform oil or gas pipeline rises. And then arrangement means the orientation and assemblage of the equipment in the facility that's been separated. So this is to illustrate, this is an example of a production facility. You have the production platform in a separate platform, and it is separated from the quarters platform. So the staffs and personnel are on a different platform. The wellhead is in a different platforms because this is where all the risers and the pipes are, and the flare also must be away from the production platform because this is an ignition source. If you have a vapor cloud happening here, you don't want it to be very close by to the flare. All right, so now that I've mentioned the vapor cloud, the vapor cloud can happen, and as long as it doesn't meet an ignition source, then it's fine if it gets dispersed and diluted. However, there's always ignition source everywhere around us. The most common ignition source is sparks that results from static charge buildup and sudden discharge. A static charge buildup is a result of physically separating a poor conductor from a good conductor or another poor conductor. So it's basically a charge build up from two different materials. For example, it can be from as simple as walking across a rug when you are while wearing a socks, a flammable, a socks that is from a flammable material, and you walk across a rug that is made out of a different material than the socks, or from your shoes. And even as simple as removing your sweater, if you remove your sweater, that also can cause static electricity, because if it rubs against your hair, that can cause a static to happen. If you can try this, if you try, sometimes even your blankets, if you try staying in a dark room, you rub your hair with the blanket, and you can actually see the statics, electricity sparks above your hair. I know my kids have done this before. And then as simple as combing your hair, brushing your hair, that causes static electricity. And static electricity is especially even easier to happen in cold weather, cool and dry weather. Okay, if we talk about ignition sources in hydrocarbon facilities, besides all those common ignition sources, the major generators of static electricity at hydrocarbon facilities can be flowing liquids or gases that contains impurities. So you can see that even liquids, if it flows in the pipeline, if it contains some impurities, that can also cause some static charge. Spray liquid is also a source of ignition, because spray liquid has different charge. Mixing of liquid or blending operation is also a potential source of ignition point. Why is this? It's because you know that liquids, different types of liquid, if you mix them together, they have different kinds of ions. So these different kinds of ion can it transfers electron, right? So that electron, if it jumps out, if there's a space between the liquid and maybe another material, the electron can actually jump, and that jump of the electron is that static. And not forgetting moving machineries, there's always friction, as well as from the personnel itself, which are the common ignition source. And possibly, yes, maybe if you have an engine moving, that is already an ignition source. So now we know that we cannot run away from these ignition sources. There's always ignition source around the hydrocarbon facilities. So how do we control them? Static electricity, it can be overcome or controlled by several basic approaches, such as bonding and grounding. So bonding is what you do is you try to achieve a common electrical potential over all of the equipment, so that a charge does not have the opportunity to accumulate. For example, if you have one equipment here and another equipment next to it, the space between the two equipments can cause static charge buildup. So the equipment has to be connected, and this is what you call bonding, to make sure that it both has a common electric potential. They both have the same charge. And not just bonding, so you bond all of these equipments, you need also to do grounding. Grounding is the process of electrically connecting that equipment to the ground potential. Okay, so you ground it so that there will be any static between that object and the ground. So everything is grounded. Okay, now control and implementation. Process control maintains variables at set points, which are fixed at some desired values. For example, you fix the temperature, you fix the pressure, you fix what is the level of the liquid inside a tank, for example. So without adequate and reliable process controls, an unexpected process occurrence cannot be monitored, controlled, and eliminated. So that's why we need to have these control instruments. An alarm has an annunciator and visual indication. So alarm makes a loud sound, and it also has a red light, for example. So that acts as a visual indication. So you can see from far if you can't hear anything because it can be loud in the plant. And then once the alarm has been set off, it then requires somebody to work upon it. You can't just, you hear the alarm, you see the lights, you just sit there and do nothing. So you have to act. And this is when the plant operator must decide what to do next. Okay. So normally you have the control instrumentation system is in a control room, so you can see the different lights. If they are green, that means you're okay. If suddenly one of the lights is red, then the plant operator must decide, oh, there's a red light here, so I have to do something. It's on that reactor, for example. Now, an emergency shutdown system, ESD, is a method to rapidly cease the operation of the process, to stop it, because you want to isolate it from incoming or outgoing connections or flows, to reduce the likelihood of any unwanted event from occurring or from continuing or from escalating further. So facilities that do not have the capability to immediately provide an emergency shutdown should be considered as high risk. So similarly, if the reliability of an ESD system is very poor, then it means that it has a it's working on a very high risk. An ESD system must be designed so that several mechanisms can initiate a facility shutdown. So this is a must. Okay, so now let's look at what are the methods of fire suppression that is available. The objective of fire suppression system is, first of all, you want to provide some cooling. So once there's a cooling, you can control the fire or prevent it from spreading, and then to extinguish the fire incident. Okay. So there are several methods of fire suppression. And these are some of the methods, but there are actually more. So one of it is using a portable fire extinguisher. Secondly is to have a sprinkler system. Another example is water deluge system, water spray system, water flooding, and steam smothering, and as well as the water curtains. Okay, so now let's take a look at fire extinguishers. Okay. Portable fire extinguishers, those heavy, red. So this is the most common method of extinguishing hydrocarbon fires in an incipient of stage, and this is also a compulsory equipment to have in any plants or buildings. A portable fire extinguishers are specified by the different types of fires. There are actually different types of fires. There's fire type A, type B, type C, or D, and also specific on the expected area of the suppression. Types of fires are grouped according to the type of material that is burning. Okay. For example, Class A fires are fires that starts on ordinary combustible materials such as wood, cloth, paper. Okay, if they're burning, so that is classified as a Class A fires. Now, Class B fires are those in which flammable liquids, oils, and grease are burning. So when you have hydrocarbon burning, so that is Class B. Okay. And Class C are fires that involve live electrical equipment. So if you have short circuit in a system and then it causes fire, then that is Class C. And Class D is fire involving it involves chemicals or combustible metals, very reactive elements such as magnesium, potassium, and sodium. Okay, so this is how you remember. Class A is all those ordinary stuff like cloth, okay, or wood, papers, Okay, so paper burning, your cloth, wood. So those are all class A. And class B is when you have hydrocarbon fires, okay, flammable liquids, flammable oil, flammable grease. Class C is those involving electrical circuit when you have a short circuit. And finally, class D involves reactive materials or combustible metals such as magnesium, potassium, and sodium. Now, so there are different types of fire extinguishers for different class of fires. So for class A fires, which are the fires that start from wood or cloth, papers, the fire extinguishers are usually water-based. So you can extinguish them using water because the water would provide a cooling effect or heat absorbing effect on that burning material to extinguish the fire. A pressurized water extinguisher normally uses air under pressure to expel the water. Now, for Class B fires, which are fires caused by flammable hydrocarbons, Class B fires can be put out by excluding air by slowing down the release of flammable vapors. If you remember the fire triangle, you need to have an oxidant, which is air, you need to have the fuel, and an ignition source, right? So if you eliminate one of it, right now, if you eliminate the oxidant, which is the air, so this fire extinguisher slows down the release of flammable vapor by interrupting the chain reaction of the combustion. Okay? So there are three types of extinguishing agents. It could be carbon dioxide. So once you spray carbon dioxide, it will eliminate the oxygen in the system. It can also be a dry chemical or a foam water. So all these will stop the the introduction of oxygen into that fire. Okay, for Class C types of fire, which is fire caused by electrical circuit. So the extinguishing agent must be electrically non-conductive. So both CO2 and dry chemicals can be used in this case because they are not conductive. And finally, for Class D fires caused by their active metals, you need to have a heat-absorbing extinguishing medium for fires caused by these combustible metals. Okay? And you also must make sure that the extinguishing medium must not react with the burning metal. Okay, now let's look at the different types of fire extinguishers and guides on how to use it. If you have a Class A fire, which is a fire from carbonaceous materials, you may use water, you may use dry powder, foam, and wet chemical, but do not use CO2 or special powder. If the fire is Class B caused by flammable liquids or hydrocarbons, do not use water, do not use wet chemical and special powder. You can only extinguish the fire using a dry powder, foam, or CO2. And if you have a flammable gas, also do not use water. You must only use dry powder. Foam doesn't work too. Flammable metals, this is Class D. Class D can only be extinguished using a special powder. Electrical equipment can be extinguished using a dry powder or carbon dioxide. And cooking oils, such as the canola oil or corn oil, must be extinguished using a wet chemical, because this is you are stopping oxygen into the system. Okay, so that was fire suppression. Another type of fire suppression which can be installed in homes are sprinkler systems. So sprinkler systems are commonly provided to indoor occupancies, such as in warehouse and offices and shopping malls and even houses and apartments. And it is considered essentially 100% effective for fire suppression if it is properly maintained and the hazard has not changed since the original design. So you have to make sure that the sprinkler system is not covered in cobweb, for example, so that it can detect the heat or the smoke. So the sprinkler system is activated by the heat of the fire that will melt a tension-loaded cap at the sprinkler head. So once it melts, it will activate the sprinkler system, okay, because it melts away or falls away. It will release the water from the pipe distribution network that's connected to that sprinkler system. So that means that the sprinkler system, they do not activate only until a fire condition is absolutely real. A water deluge system is just like a sprinkler system, but it has more, it is more intense. And it should generally be activated by automatic means, because if you activate it by manual means, it just defeats the purpose or the objective of installing a deluge system. So this is normally provided at petroleum facilities. You don't put this at homes, okay? And it's typically activated by a heat detection system. If you put it in your homes, you will flood your house. Okay. Water flooding. So water flooding is the principle to inject water into the interior part of a storage tank for the purpose of preventing flammable or combustible liquids from being released from a leakage point or to extinguish the fire. So there's different reasons for doing this. One is to stop it from the combustible liquid from being released from a tank, as well as to use it to extinguish a fire. Okay, so the principle involves filling a vessel or that tank with water so that the lighter density hydrocarbon will float on top of the water, and when you release it, you only release because you want to release the pressure, right? So you will only release the water from the tank and not the hydrocarbon. Okay, steam smoldering is also another method of fire suppression. It's typically limited to fires that might occur as a result of a tube leak in a furnace or a heater. The steam is most effective in smothering fires when they are located in relatively small confined areas, and steam extinguishes fires by the exclusion of free air and the reduction of available oxygen content to the immediate area, similar to other gaseous suppression agents. And finally, that is the end of the slide. Before that, let's summarize the different things that we have covered under fire protection and fire suppression. So first of all, we have covered the 6 layers of protection, and then which also included our segregation, separation, and arrangement. And we looked at an example of a offshore oil platform. And then the control of ignition point. How do you control static electricity, for example, by bonding and by grounding? And then we discuss on control and instrumentation system, how alarms work, how they should work, how the lights or visual indicators should work, and what it means. And then the emergency shutdown system. And finally, fire suppression methods available, but not limited to only these. There are also many different types of fire suppression methods. If you Google, you will find a lot of different methods. So what was discussed was fire extinguishers, sprinkler systems, water deluge system, water flooding, and steam smothering. And that is all for this topic. And thank you very much.